Okay, we're on number 8. It says using the limit definition, prove the limit is x goes to 5, which is a finite number, of the root of 3x plus 1 is equal to 4, which is also a finite number. So a traditional epsilon delta definition of the limit. Let's go to the whiteboard, and we'll try to do number 8 now. All right? And I think this is the first root problem we're doing in the set. All right, so it's number 8. And they want me to prove this limit over here. Limit x goes to 5 of the root of 3x plus 1 is equal to 4. And let's just make sure that's true, by the way. 3 times 5 is 15. 15 plus 1 is 16. The root of 16 certainly is 4. So it's going to be an epsilon delta problem. And what do? We start off with a given. The given we start with is that epsilon, there is some epsilon greater than 0. All right? The next part, the tough part, because I really don't know what it is, but we need to choose a delta now. I don't know what it is, by the way. So the question is, how do you do it? Well, you're going to suppose something. And you're going to suppose that the distance between x and 5 is less than delta. And I'm going to write that as an absolute value, as x minus 5, less than delta. Furthermore, I don't want x to touch 5, so x is not equal to 5. If x is not equal to 5, x minus 5 is not equal to 0, nor is the absolute value of that. So that means this is greater than 0. All right, so we got that. Now what do you do is check part. This part was probably the most work. The absolute value of the function, 3x plus 1 minus the limit, which is 4. Now looking at that, this is going to lead, hopefully, to an epsilon in the end. All right, but I'm looking at it, I wonder how that's going to happen. So I'm going to just review a couple different things that you might have done with limits, and certainly, conjugates work out. So let's just play around with this over here. 3x plus 1 minus 4. I'll put it over 1. I'm going to multiply the top and the bottom by the top's conjugate. Well, it looks bad, doesn't it? And let's see what happens on the top. You get 3x plus 1 minus 16. All right? The bottom, you get this over here. Again, I'm trying to see what that's going to give me, by the way. And what do you get there? You get 3x minus 15 on top. On the bottom, you get this over here. And again, it's almost a dead end. Where's this taking us? Let's keep moving. And the one thing I do notice is I notice 3 times x minus 5 on top. Now someone says, why do you notice that? I'm seeing that in the supposed part, and that's my delta right there. And the bottom, I'll put this over here. Now what I want to do is go up here and write that down now. And this is equal to, and what's it equal to? It's equal to 3x minus 15. I'll check that again, by the way. Over 3x, the root of 3x plus 1 plus 4. All right, let me go back and check to make sure I wrote that right. 3 times x minus, 3x minus 15, yep. And 3, yep, I got this. Let me just rewrite the top a little differently, because I realize that although it's 3x minus 15, I get it as 3 times x minus 5. Okay, one thing I noticed, like right off the bat, that I can pull a 3 out. That's something for sure. And then I get this over here, the absolute value of x minus 5. And on the bottom, what I notice is the absolute value of the bottom, well, 3x plus 1, now let's think about that. It's a root, so it's a principal root. It's going to be a positive number plus 4. So this thing here is always going to be greater than, I'm sorry, let me get my eraser out again. This thing here is always greater than 0. So I can remove the absolute value now. All right. Now, going back to this delta business, I'm going to write this down now. This will be, let's see, less than. And I'm looking at this over here. I'm going to say 3 delta. And then this bottom part, I'm thinking about it. And the question is, what's the least it could be? All right. And, the least is really a worst case scenario on it. because that's when the fraction, maybe I shouldn't say the least. I'm looking at this over here. Let me try to rephrase that more intelligently. I'm looking at this over here, and maybe I should say the most it can be. No, the least. And the most is, it's could be infinite, right? The smallest it could be would be 4. So let me write this over here. 3x plus 1 plus 4. That this thing here will always be greater than 4. All right? It'll always be greater than 4. All right? On the domain, anyway. All right? So, if that's always bigger than that, right, that this is bigger than this thing over here. All right? It's bigger than that. So what I'm going to do, I'm going to put a 4 over here now. And let me just think about that. And you know what? It makes sense to me. I'll tell you why. If this is bigger, this whole thing would be smaller. All right? So that makes sense to me. Now I've got something over here, and now I could say this is equal to epsilon. Now I got to pick a delta now where that would equal epsilon. So let's write this over here. 3/4 of a delta equals epsilon. So delta would equal 4 epsilon over 3, or 4/3 of an epsilon. I think I'm ready to write this down then. 4/3 of an epsilon. And again, I want to remind you that this is greater than 0. All right? So we're done. And that wasn't such a bad one to do, by the way. That's the last step of it. What do we write down? QED. And the work we did, right? QED. What does black pen, red pen write down? A square box. And then he shades it in. All right? Whatever works for you. Thank you.